Today we'll be doing the integral from 0 to 1 of the natural log of x times the inverse tangent of x dx. And to start off, we could use integration by parts. So we're going to let u equal ln x, which means that du equals 1 over x dx. We could let dv equal the inverse tangent of x, which means that v equals the integral of the inverse tangent of x. And I already did a video on this. It's going to be x inverse tangent of x minus the natural log of the square root of 1 plus x squared. So using integration by parts, we have that ln x, x inverse tangent of x minus the natural log of the square root of 1 plus x squared from 0 to 1 minus the integral from 0 to 1 of v x inverse tangent of x minus the natural log of the square root of 1 plus x squared times du 1 over x dx. And as x approaches 0 and x approaches 1, this entire thing goes to 0. We're left with negative the integral from 0 to 1 of x inverse tangent of x minus the natural log of the square root of 1 plus x squared over x dx. We could separate the x, and we have negative the integral from 0 to 1 of x inverse tangent of x over x plus the integral from 0 to 1 of the natural log of the square root of 1 plus x squared divided by x dx. Here the x's cancel. We're left with negative the integral from 0 to 1, the inverse tangent of x, plus the integral from 0 to 1 of the natural log of the square root of 1 plus x squared divided by x dx. And we already know what this integral is. It's negative x inverse tangent of x minus the natural log of the square root of 1 plus x squared from 0 to 1, and then plus the integral from 0 to 1 natural log of the square root of 1 plus x squared over x dx. So valuing at the bounds, we have negative tangent inverse of 1 minus the natural log of the square root of 2 minus 0 inverse tangent of 0 minus the natural log of the square root of 1 plus the integral from 0 to 1 natural log of the square root of 1 plus x squared over x dx. Inverse tangent of 0 is 0, and the natural log of 1 is 0. So we're left with negative inverse tangent of at 1 is pi over 4 minus the natural log of the square root of 2 plus the integral from 0 to 1 the natural log of the square root of 1 plus x squared over x dx, which is equal to the natural log of the square root of 2 minus pi over 4 plus the integral from 0 to 1 the natural log of the square root of 1 plus x squared over x dx. We now have that our integral is the natural log of the square root of 2 minus pi over 4 plus the integral from 0 to 1 of the natural log of the square root of 1 plus x squared over x dx. And now we'll focus on this other integral. So you have the integral from 0 to 1, natural log of the square root of 1 plus x squared over x dx. You can rewrite this as 1/2 the integral from 0 to 1, the natural log of 1 plus x squared over x dx. And using the series representation of the natural log of 1 plus x squared, we have 1/2 the integral from 0 to 1, the sum from 1 to infinity, negative 1 to the k minus 1, x to 2k over k times 1 over x dx is equal to 1/2 the sum from 1 to infinity, negative 1 to the k minus 1 over k, the integral from 0 to 1 of x to 2k minus 1 dx is equal to 1/2 the sum from 1 to infinity, negative 1 to the k minus 1 over k, x to 2k over 2k from 0 to 1 is equal to 1/2 the sum from 1 to infinity, -1 to k minus 1 over 2k squared. We could bring down the 1/2 to the front. We have 1/4 the sum from 1 to infinity, -1 to the k minus 1 over k squared, which is 1/4 the eta function at 2, which is 1/4 times pi squared over 12, is equal to pi squared over 48. So we have that the integral from 0 to 1, the natural log of x, inverse tangent of x dx, is the natural log of the square root of 2 minus pi over 4 plus pi squared over 48. And this is the final result. Thank you very much for watching.